BYJU'S Exam Prep. So I'm Vikas and in the last lab to IPMAT series, we will do today importance of higher mathematics. So higher mathematics we will take up today. Yes, hello everyone. Good afternoon. Hello, Fataha. Yes, good afternoon everyone. ओके जल्दी से शेयर भी कर दो, अपने फ्रेंड्स को भी बता दो सेशन स्टार्ट हो गया है. Okay, so today we will do matrices and determinant in the higher mathematics. Questions based on matrices and determinant. Okay, so you can see the topics under higher maths. Okay, I'm just showing the topics under higher maths. Okay, let's see. These are matrices, determinants, trigonometry, solution of triangles, binomial expansion, complex number, and application of calculus. Okay, they have reduced the weightage. Somehow they have reduced the weightage. We are particularly talking about IPMAT Indore. Right? This session is particularly for IPMAT Indore. So if I talk about the weightage to this topic, right, the topic higher maths, total higher maths, so including every subtopic, the total weightage is, right, you can see that initially it was approximate 8 to 9 questions, but now reduced to 6 to 7 questions. Okay, now it is reduced to 6 to 7 questions. But if I talk about particularly matrices and determinant, right, जो आज हम discuss करने वाले हैं, right, we are going to discuss matrices and determinants today. तो इस पर्टिकुलर टॉपिक को मैट्रिसेस एंड डिटर्मिनेंट की अगर मैं वेटेज की बात करूं, राइट, then the weightage to this topic is, you can see, the initially it was approximate 4 questions, now it is 3 questions. It may be 2 plus 1 or 1 plus 2, that is 2 short answer and 1 MCQ, or 2 MCQ and 1 short answer, right? Generally it is 3 questions. Okay, in the new pattern you can expect 3 questions out of this topic, right? But again if you are not, yes, this is for IPMAT Indore RN, yes, particularly for IPMAT Indore. Or if you are going for mathematics as a domain subject in CUET, okay, then also you can just go through this. Okay, so that will be important. Right, now the thing is, I keep telling you that in IPMAT Indore, right, that quant section, that mathematics section, quant section, right, you need to score only if you get 8 correct in MCQs, right? If you get 8 correct, okay, IPMAT Indore, okay, we talked about this topic. These are the topics, right? When I talked about matrices, determinant, trigonometry, and some application of calculus also. But the thing is, Anushka, I keep telling that, right, even if you score 8 correct, right, 8 correct answers in your MCQ, right, only MCQs I am talking about, then definitely, right, you are through to the second stage. Right, I'm talking about out of 40 questions, that is only 20%. Only 20% of the questions if you attempt. Right, that means you can leave many questions. So that is the key in IPMAT Indore. So you can selectively attempt. Okay, so no need to do everything, but if you can skip that and devote that time to those questions which you can definitely get it correct. Okay, so strategy part plays important role. Okay, for IPMAT Indore I am talking about, nothing else. Okay, so let's recap. Okay, AD, but what is the use, right? You just see that total they are asking 6 to 7 questions. If I am revising everything, derivative, integrals, everything you can just go through the formulae, right? Nothing else, right? If you revise everything, you are devoting that much time, you are getting only 1 or 2 questions out of that, right? There is no use. Okay, so just practice. Okay, it's I think 20 questions in the short answer. Okay, so integral, it is rare. It is right. It is very difficult to get a question on integral, because overall, right, you can see that overall there will be only 6 to 7 questions from the higher maths. Right? Okay. So let's start with the recap of matrices and determinant. First, just do this, right? Okay, my suggestion is you just go through the formula. If you have done +1 +2 mathematics, right, you just go through the. Okay, new pattern. I'm just talking about that the in the okay, recent times, okay, or you can say last 2 years, they have reduced the number of questions that they are asking on higher mathematics. Kushi, it is not the pattern we are talking about, but the number of questions on higher math, they have reduced to around 6 questions. Right, earlier it used to be 8 9 questions, now it would be 6 questions or 7 questions, let's say, right? So that will be very less. So out of that you will get questions on matrices determinant, right? 2 3 questions on matrix determinant, then you will get question on trigonometry also, right? So I don't think so there is no need to do that entire calculus stuff. Okay, but if you know the formulae, that would be okay, right? If you know the formulae, that's great. Okay, now I'm just revising matrices and determinants. So what first is, what will be the safe score? So anything above 30, okay, above 30 in your MCQ part, right? In MCQ part it would be above 30, and then you can say that close to 20, right? 20 in your essay part, right? And 70 minimum in your verbal part, right? So this is the minimum score I am talking about in all, and you can get if a total you can get more than 130, it would be definitely a safe score, right? Okay, so let's start with this trace of a matrix. Trace of a matrix is very easy, right? It is the sum of the diagonal elements, right? Sum of the diagonal elements. Okay, just see. Oh, you can see the definition, but otherwise I am giving you one example, right? Just see the example. In the example, it is given a 4 cross 4 matrix, right? Just see that the trace of this matrix will be 3 plus 1 plus minus 4 plus 5. So that means the total will become, right, 4 minus 4 plus 5. So it will be 5 only, right? 5 only. So the trace of the matrix is going to be 5. Okay. So it is sum of the diagonal elements. Okay. and diagonal you will take left top to the right bottom. Okay, this one. Okay, the first diagonal, left top, which you know what a diagonal matrix is, so you know that this is the diagonal of the matrix. Okay, so next one is, okay, next one is transpose of a matrix. Okay, just revising the terms. Transpose of a matrix is, right, changing row to column, column to row, you can say. Okay, row to column, column to row. Okay, you are interchanging the rows and column. So that means you can see that transpose of the matrix we have here given, that diagonal will remain same. This will remain same, right? Here 503 it will remain same, but this 4 will interchange by this, right? This and this will interchange, right? So both are 4. These are not changing. Here 7 and 3, this will change. So 7 will come here, 3 will come here, and this 10 and 4, this will interchange. So 4 will come here, 10 will come here. So rows to column, column to rows, it is the transpose of the matrix. Okay? सेशन को शेयर और लाइक कर देना यूट्यूब पे जो देख रहे हैं. Okay, so next पे आ जाओ. Right, now few important properties for transpose. Transpose of a transpose is the same matrix again. So first point is A transpose, then transpose. So transpose of transpose is again the same matrix. Then you have, okay, if you are adding, you can separately take the transpose and then add, or you can add first and then take the transpose, the same result will be there. Similar thing is for subtraction. You can subtract first and then take transpose, or you can take transpose first and then subtract. One and the same thing, right? One and the same thing. Okay, then the scalar quantity. Okay, this is basically the property of matrix only, right? That if it is multiplied by Ka, that means you are saying K is a scalar quantity multiplied by a matrix. That means it is multiplied, K is multiplied by every element of the matrix, right? So from every element you can take K common out of that, right? So whether it is a transpose or a normal matrix, right, K will be common to all, right? K will be in all the elements, so there is no use. So if you are taking K out and then you take A transpose, or you are multiplying first K with A, okay, K is inside only in the matrix. Okay, कुछ ऐसा है योगेश ऐसे. Suppose all elements are multiplied by 2. Okay, so it is like 2A, 2B, 2C, 2D, 2E, 2F, 2G, 2H, and 2I. Okay, this is the matrix. Okay, so basically it is multiplied by, already there is a 2 inside it. Okay, so you can say that it is, okay, if inside matrix, if you are taking A as only ABC, you can write it as 2A. That means A is only A, B, C, D, E, F, G, H, I, and 2A is 2A, 2B, 2C, right? Now you can take the this transpose of the entire matrix like this, that 2A transpose, right, will be, you will write 2A, 2E and 2I, and now you will have 2B, 2C, 2D, 2E, 2F, 2G, 2H, 2I. So this you can write, or you can take that 2 common first, right? 2 common first and take A's transpose. Now A was only ABC, A, B, C, D, E, F, G, H, I. So this was your matrix A, right? So you can take 2A and take the transpose of A. Transpose of A will be A, B, C, D, E, F, G, H, I, right? So this is basically 2 into A transpose. So this value and this value are same. right? These are equal, right? Equal. So that is what this property says, that K into A and taking the transpose is equal to KA, right, whole, taking the transpose, or K common and A transpose. Okay, one and the same thing, right? This K must be a scalar quantity. Okay, the next one, right? Next one is that if you take A into B transpose, that can be written as B raised to B transpose into A transpose, right? That means you multiply this first, A into B, multiplication of matrices, I will tell you, right? A into B, and then take transpose. That will be same as B transpose into A transpose, because matrix multiplication is not commutative, right? That means in matrix multiplication, A into B is not equal to B into A, right? A into B is not equal to B into A. So that's why A into B taking a transpose is equal to B transpose into A transpose. Okay, so these are basic formulae we are talking about. Now symmetric and skew symmetric. So symmetric is when you take the transpose, right, you get the same matrix again. Okay, if you take the transpose and that is the same matrix, that is your symmetric matrix, right? Okay, it is something like, I will take an example, right? So it is basically A transpose is equal to A, right? Transpose you can write T or dash, complement types. So A transpose equal to A, right? You see the example, you will get to know, right? Just see the example, right? Here you see that if these elements are equal and these are equal and these are equal, right? So when you take transpose, this will be the same thing. So matrix B and matrix B transpose are same, right? You can see that clearly B equal to B dash. So that means symmetric matrix is of the form of, right? I'm writing symmetric matrix. It may be, the diagonal may be anything. You can write any order, right? We are writing 3 cross 3 matrices. You can write any order. So A, B, C. Now if you write D, E, F here, so D, E, F here, right? Then this is a symmetric matrix. Okay. This is the structure of symmetric matrix. Okay, which you can say lower triangle is equal to the upper triangle. This is your lower triangle, no? This is your upper triangle. If your lower triangle is equal to upper triangle, then it is, okay, same. Symmetric matrix. Skew symmetric is when you take that transpose and it is negative of the original matrix. Okay, just see that if while taking a transpose of a square matrix, we get the original matrix, but the polarity is changed. Polarity means the signs are changed, right? And now you are getting, okay, so mathematically you can see here that A transpose is equal to minus A, right? Your sign changes. Now how can that sign be changed? Because in symmetric, the diagonal was same. The diagonal was same, but now the sign is to be changed. So diagonal, right, because the diagonal in transpose, taking the transpose, diagonal will not change. So diagonal, but I need the different signs. So how it is possible? So make the diagonal 0. So in skew symmetric, the diagonal must be 0. Okay, just see. If I take the diagonal as 0, right, diagonal as 0, right, because it has to be, if you change the, now minus 2 and 2 will interchange, 45 and minus 45 will interchange, and 4 and minus 4 will interchange, right? Now this matrix A will be negative of minus, okay, or transpose will be negative of A, right? So the diagonal of a skew symmetric matrix is always 0. So if I write the structure, okay, Mickey, it depends that where else you are getting admission, right? We can compare the universities, we can compare two different B schools, right? But if you say a particular university, yes, they are doing BBA, MBA, so it would be good. But the thing is, if you are getting, let's say you are getting admission in Delhi University, so I will say Delhi University is better, right? Okay, now I am writing the structure of skew symmetric, so it will be 0, 0, 0. And if you write A, B, C here, so it will be minus A, minus B and minus C here, right? Okay, so this is the structure of skew symmetric matrix. Okay, let's move to the next one. Right, now matrix inverse. Right, for inverse you need to know that what is a minor, what is cofactor, transpose, adjoint. So combination, it will become that A inverse is adjoint of A divided by mod of A, right? And you know that adjoint of A is the transpose of, okay, transpose of matrix of cofactors, right? So transpose of matrix of cofactors would be adjoint of A, right? But generally, right, this A inverse, whenever he asks A inverse question on inverse is there in the exam, right, you will use a certain property to check the inverse, because calculating this inverse like this, okay, Blazigun, hello, right, good afternoon. Now, calculating the inverse like this will be a difficult task. This will be a lengthy task. Okay, matrices and determinant we are doing. Okay, so we will use the properties to check whether it is a correct inverse or not. Okay, let's see. Let's see in the questions I will tell you. Now, few important points about inverse, right? That is, yes, okay, I will tell you that. So AB inverse is B inverse into A inverse, like the transpose, right? A into B transpose equal to B in transpose into A transpose. This is same. A into B inverse is equal to B inverse into A inverse, right? Similar to the transpose. Now, similar thing is extended to three things also. A into B into C inverse is equal to C inverse into B inverse into A inverse, right? Then you have A inverse transpose is equal to A transpose inverse. This is also true, right? That is A inverse and then transpose, or A transpose then inverse. It is true, right? Okay, now if A is orthogonal, what is orthogonal matrix, right? What is orthogonal matrix, right? Orthogonal matrix is, right, when you say orthogonal matrix is when you have A into A transpose equal to I, identity, right? But I also know that A into A inverse is also identity. So that means for orthogonal, A transpose is always equal to A inverse, because A into A transpose is also identity in case it is an orthogonal matrix. That is the property, that A into A transpose is equal to identity, but A into A inverse is also identity. So A inverse is equal to A transpose in the case of orthogonal matrix. Okay, just go through the property. We need to do questions also, right? There is very less time. Okay, so now we are talking about if the determinant of a is X, right, and A is a square matrix of order n, then Ka. Now Ka in a matrix, Ka means, right, if A is, let's say I am writing only A, B, C, D, okay, then Ka would be, right, K into A, Kb, Kc and Kd, right? Okay, this is like this. But when you take determinant, right, when you take determinant of that, right, then you can take from every row, you can take K common. So that means if there are two rows, so you can take for determinant, you can take that if A determinant is X, so it will become K raised to power 2X, because you can take K from upper row, K from lower row common, and then A, B, C, D determinant is X. So similarly, we are talking about if determinant of A is X and A is a square matrix of order n, then K into A, if I take determinant of that, it will be K raised to power n into X. So you can take K from all the n rows. So K into K into K n times, it will become K raised to power n into X. Right? Okay, and then I already told you that A into A inverse is identity matrix. Okay, this property is very useful. We will use this property to check. Now determinant properties. Okay, so here error was asking that property of determinants. Okay, just go through few properties of determinant. Okay, first thing is, right, if it is an order, okay, this is basically how to calculate the determinant. How to calculate the determinant. Okay, so property 5. So property 5, which one? Oh, so this is the property. Okay, okay. Now here first property of determinant is actually calculating the determinant of a matrix. Okay, so when you calculate the determinant of a matrix of square matrix of order n, then the sum of the product of elements of any row or column with their cofactor is always equal to this, right? Because this is how you calculate the determinant value, right? This is the method to determine the value. Like if you have, let's say 1 2 3 4 5 6 7 8 9. So here we are talking about you can take any row or column. So you are taking this and then cofactor. Cofactor of 1 would be, right here you will write cofactor of 1 would be, because it is first row first column, so it will become plus, right, and 45 minus 48, right, like this. So this is plus, this is the cofactor into 1, right? Then it will be second element of row is 2, right? Now the cofactor will be minus, because second row first column it is odd, sum of the row and column is odd, it will be minus, and this will be 42 minus 36. Okay, so sorry, it would be 36 minus 42, right? 36 minus 42. Okay, like this, right? Then the third would be, right, it would be plus 3 and it will be 32 minus 35, right? So this is basically property 1 is how to calculate the value of the determinant. Okay, the second is if A and B are square matrices of the same order, then A into B determinant is equal to A determinant into B determinant if they are square matrices of the same order, right? So first multiply and then take the determinant. Actually determinant, that transpose doesn't matter. If you take the transpose of any matrices, the determinant value is going to be the same, right? Determinant will not change. So here A into B determinant is equal to determinant of A into determinant of B, right? Okay, the next one is, now this is what I was talking about, whether you take the determinant of A or whether you take transpose of A and determinant of that, right, the value is same, because changing row to column, column to row, it will not change the value of the determinant. Okay, then the next thing is, okay, here we are talking about if we interchange, okay, interchange two rows or two columns in the matrix, and let's say we are getting a separate matrix C. So determinant value of C will be minus of determinant value of A, right? If you change two row or two column, right, interchange, okay, and then take the determinant value, it will be minus negative of the initial one, okay. Now next one is, if any two rows or columns of a square matrix of order greater than or equal to 2 are identical, किसी भी डिटर्मिनेंट में, किसी भी जो भी मैट्रिक्स आप ले रहे हो जिसकी डिटर्मिनेंट वैल्यू आपने कैलकुलेट करनी है, उसकी दो रो या दो कॉलम अगर आइडेंटिकल हैं, राइट, तो उसका डिटर्मिनेंट वैल्यू जीरो है, राइट, डिटर्मिनेंट वैल्यू क्या है, जीरो, ओके. Now, so this I already told you, right? This we have already discussed, right? That point number 5 in that earlier thing, right? In inverse property, this was the same. Okay, so k into a. Okay, we have already discussed this. That k raised to power n into determinant of a. Okay, and then last property. Okay, we will say, then we will move to the questions. The determinant of a skew symmetric matrix of odd order is always zero. Skew symmetric because the diagonal element is zero, right? If it is an odd order, right, odd order, diagonal element is zero, this is determinant is going to be zero, right? So if skew symmetric of order 3 or of order 5, right, you will get the resultant determinant to be zero, right? Value of determinant will be zero. But if it is an even order, the answer will be a perfect square. Determinant of a skew symmetric matrix of even order is always a perfect square, right? Okay, so these will be very helpful when you answer certain questions, right? Okay, so here I am taking few questions, right, on these matrices and determinants. Okay, there are many more things that you can revise, right? More formulae you can revise from your +1 +2 books. Okay, so let's see. Let's discuss few good problems on matrices and determinant. So first problem. Find the maximum number of different elements required to form a symmetric matrix of order 10. Okay, he's saying maximum number of different elements. What maximum number of different element possible? Okay, just see, right? If I take it like this, that I told you that the structure of a symmetric matrices is A, B, C, D. Okay, let's take only three. Okay, let's take only three. A, B, and C. Right? Now, if you have here D, E, and F, here it will be again D, E, and F. Right? So these three will be same, right? Repeated. But we have already taken here. So that means your distinct element possible are only in this area, right? So if it is a 3 cross 3 matrix, then you have one element, two element, three element. So 1 plus 2 plus 3. So you can have maximum of 6 different elements. So if you have order 10, then you have 1, 2, 3 up to 10, which is n into n plus 1 by 2, 10 into 11 by 2. So 55 distinct elements you can have. Because on the upper triangle, okay, you can say upper are different and lower are repeated, one and the same thing. So if I'm saying lower are different, 1, 2, 3, 4, 5 up to 10 diagonal in that 10 element in the diagonal. After that it will be all repeated because symmetric matrix, it has to be repeated, right? So the distinct element possible are from 1 plus 2 plus 3 plus 4 up to 10. So 55 elements, right? Okay, so let's move to the next one. So 55 is the correct answer. Now, what can be the value of x for which given matrix is singular? Oh, singular matrix is, what do you mean by singular matrix? Where, right, where the determinant value of the matrix is 0, right? Matrix A is said to be singular if determinant of A is 0, right? Okay. So at what x you can have this determinant to be 0, right? I told you that if two rows or two columns are same, right? Then it will become, okay, so if x plus, okay, let's say this 2 and 2 are same, so -1, so if I take x to be 1, 1 minus 2 will be -1, so this will also be same. If I take x1, 1 plus 2, this will be same. So that means at x equal to 1, yes, at x equal to 1, so all the rows will become same actually, right? So if two identical rows, the determinant value is 0, so it is a singular matrix, right? Okay, so let's move to the next one. So one was correct. Let's move to the next question. Right? Okay. I will tell you one general thing about this question. Right here we have no choices. Okay. So this is a short answer question type. That means you need to type the answer, not that MCQs are not there. Right? Multiple choices are not there. So here, if somebody asks for a higher power, a raised to power 2012, right? You cannot calculate that power. There has to be certain generalization, right? कुछ तो जनरल फॉर्म होगी, right? कुछ जनरल फॉर्म होगी तो जनरल फॉर्म बना के देख लो, right? अभी ये ट्रेस की बात कर रहा है, right? Currently trace is 3 minus 1 is 2, right? Currently the trace is 2. Okay. Now see, if you take a square will be 3 minus 4, 1 minus 1 into 3 minus 4, right? 1 minus 1. So let's multiply it. You know how to multiply. First this row with this column. So 3 into 3, 9, 9 minus 4, 5. Right? Then this row with this column. So 3 into minus 4, minus 12. And this will be 4. So minus 12. So 3, 9 minus 4, 5. So here it will be minus 12 and 4 minus 8. Right? And here this will be 1 into 3. The next element will be 1 into 3 minus 1. That will be 2. So then into 1 minus 4 plus 1 minus 3. Right? Okay, this is my a square. And in a square, what is the trace? The trace is again 5 minus 3, it is 2. Again it is 2. Right? Okay, let's try to find out a cube. Okay, let's try to find out a cube. So a cube will be 5 to minus 8 minus 3 into 3 minus 4, 1 and minus 1. Right, a square into a I am taking. So it will become 5 into 3, 15 minus 8, 7. 5 minus 20 plus 8 minus 12. Right, 6 minus 3, 3. And it will be minus 8 and plus 4, so minus 4, minus 8 plus 3 minus 5, right? 7 minus 5. Now the thing is, here also, if you see the trace is again 2, 7 minus 5 is 2. So that means whatever value I am taking, a square, a cube, a, trace is always 2. So the trace of any power of a is going to be 2 only. Right? Okay, so a raised to power 2012 also I will get the trace 2 only. Right? Trace is the sum of the diagonal elements. Okay, so let's move to the next one, and the answer should be here 2. Yes, 2 is the correct answer. So let's move to the next question. Now, if A is a square matrix of order 3 such that A, determinant of A is 2, then adjoint of A and then determinant of that. Okay. So if you can't think of any property, if you cannot think of anything, right, what you can do quickly, right, what you can do quickly is take any matrix of order 3 where the determinant value is 2, right? How can you take that, right? So I will take this as that first element I am taking 2, right, and then to the now this will have, right, this will have the determinant value as 2 only. Right, determinant value will be 2 into 1 minus 0, so that is 2. Rest elements are 0, so no need to take anything else. So if this is A, right, this is A, right, you know determinant of A. So now take the adjoint of A, right? So adjoint of A, if I take, right, adjoint of A is the transpose of, okay, transpose of the matrix of cofactors, right? So only take cofactor, because transpose will not work, because the lower triangle and upper triangle both are zeros. So 0 changing to 0, so that will not work. Only thing is that here if you take, okay, what will be transpose here? 2, first cofactor will be plus and 1 into 1, 1. Okay, 1, right? Transpose of this will be, okay, cofactor of this will be, again it will be plus, because row, second column. So it will be 2 into 1, 2. Now for this, it will be again 2 into 1, 2. The rest is 0 only, right? Okay. Now again adjoint of adjoint. So now again I will take the adjoint of this. So adjoint of A. Okay. What do you want me to explain? You know what is adjoint? Adjoint is the transpose of matrix of cofactors. Now I have written matrix of cofactors, right? Because transpose will not work here, because lower triangle is 0, 0, 0, upper triangle is 0, right? Changing this will be the same thing. I have written the matrix of cofactors only, right? You know matrix of cofactor is, right, that minus 1 raised to power row plus column, I and j is the row number and column number, right, into the minor is, okay, you will say for 1. Okay, AD has already calculated. Very good, very good, very good. So it was for that minor you will calculate here, right? Minor of anything. Okay, any element. So if it is the first element, it will be second row second element into third row third element minus third row second element into second row third element. That cross multiplication of leaving that row and column. Okay, so here adjoint of adjoint will become, now this minor of this will be, because it is plus only, 2 into 2, 4, right? This will be 0, 0, and for this 2, 1 into 2, 2, and this will be, for this it will be 1 into 2, 2. Now determinant of this, when you calculate determinant of this, right, you can take this 4 common, 2 common, 2 common from this row. So that means it will become 4 into 2 into 2 into identity 1 1 1 0 0 0 0 0 0, right? Diagonal is 1 1 1, that is unity. So 4 into 4, it will be 16, right? You know how to calculate determinant value, right? That can be calculated. Okay, so this is going to be 16, right? If you Believe me, if you don't know how to calculate adjoint, how to calculate this cofactors, okay, leave this, right? Believe me, if you leave this right at this moment, don't do this matrices and determinant then. Only if you know the definitions and you know the easy parts, that means you know how to calculate transpose, how to know calculate trace. If they ask simple question on that, you can do that, otherwise leave that. Okay? Because there are so many things that you can attempt there. Right? You focus on that then. If you have done matrices and determinant, then it will be useful. Okay, next one. Now order of the matrix. Order of the matrix, you know that when I multiply two matrices, let's say I multiply matrix A, which is m cross n, right? With I am multiplying with matrix B, which is n cross P. Now you can multiply only when the columns of first matrix must be equal to rows of second matrix, right? Then your resultant A cross B will be a matrix of the order m cross P, right? The resultant matrix will be m cross P, right? If you know this, you can handle this. Now Z, what is the order of Z, right? Z is 2 cross 3, right? This is a matrix which is 2 cross 3, right? You are multiplying this with, okay, in the bracket there is X transpose. Now transpose will become 3 cross 4, 3 cross 4, right? And with multiplying with Y, so you are multiplying this with Y, which is 4 cross 3, right? And then taking the inverse of this, okay, and then you are multiplying with Z transpose. Now Z transpose will be this will be 2 cross 3, okay, 3 cross 2. You are talking about transpose of Z, so it will be 3 cross 2, and finally you will take the transpose of the whole, right? Okay, just see. Now first thing is, when you multiply this, right, in the bracket, when you multiply, so 4 cancel, this matrix will become 3 cross 3, right? Inverse of any 3 cross 3 matrix will be the same, so this gone. Now when you multiply this 2 cross 3 into 3 cross 3, this will become 3 cancel, it will become 2 cross 3. And when you multiply this by 3 cross 3, 3 cancel, so it will become 2 cross 2, and transpose will be the same. So 2 cross 2 should be the answer. Yes, AD, error, absolutely. Right, 2 cross 2 would be the correct answer. Right, so if you know the basics of the matrices, you can answer such questions very easily. Right, if you don't know the basic, don't get into that. राइट अभी उतना टाइम नहीं होगा आपके पास ये सब सीखने का नया बिल्कुल स्क्रैच से. राइट, इफ यू हैव ऑलरेडी स्टडीड +1 +2 में मैथ्स रखा था और आपने मैट्रिसेस पढ़ा हुआ है, तब आप बेसिक पक्का कर ले. राइट, क्योंकि बेसिक से ही क्वेश्चन आ जाते हैं एंड यू विल गेट इट करेक्ट. ओके, सो लेट्स मूव टू द नेक्स्ट वन. Now the maximum number of terms in the expansion of the determinant of order n cross n. राइट, ये आप नोट कर लो. राइट, ये नोट कर लो, n फैक्टोरियल. राइट, n फैक्टोरियल. राइट, आप याद भी कर सकते हो. वैसे ये होता ये है कि आप जब n क्रॉस n डिटर्मिनेंट एक्सपैंड करते हो, राइट, ऐसा सोचो कि आपने एक 2 क्रॉस 2 को एक्सपैंड किया, राइट, सिर्फ ए बी सी डी. तो आपके पास इसकी डिटर्मिनेंट वैल्यू में क्या आएगा? a इंटू डी माइनस सी इंटू बी. राइट, सो देयर विल बी 2 टर्म्स. राइट, 2 क्रॉस 2 था, तो n क्रॉस n को आप सोच के रखो. आंसर क्या आया? 2 टर्म्स. सो 2 के लिए 2 टर्म्स आया. जब n आपका 2 था, आपका आंसर आया 2. राइट, आपने 3 टर्म्स ले ली, a b c d e f g h i. तो आपका बनेगा क्या? जब आप a लोगे तो उसके अंदर आएगा एच एफ माइनस ई आई. तो ये 2 टर्म बनेंगी, a इंटू एच एफ, a इंटू ई आई. तो ऐसे ही सेकंड अगर आपने लेट से डी लिया, ओके, या बी लिया, कोई भी आप लोगे, तो उसके लिए भी टू टर्म्स आएंगी, राइट। फिर आप उसके साथ जी लोगे, उसके साथ भी दो टर्म आएंगी। तो टू, टू एंड टू, सिक्स। तो जब आपने एन को थ्री लिया तो आपका आंसर आया सिक्स। इसी को चेक कर लो, राइट। सो एन टू आए तो टू होना चाहिए, गया। एन टू तो टू होना चाहिए, ये ठीक था। बट एन थ्री में सिक्स होना चाहिए, ये भी गया। एन टू में टू, वो भी गलत था। सो देखो, टू फैक्टोरियल टू होता है और थ्री फैक्टोरियल सिक्स होता है, तो यही आंसर है, right? When you have three terms, right, 3 by 3, 3 cross 3 matrices, okay, matrix आपने लिया 3 cross 3 matrix, then you are getting the determinant value, terms in the determinant, right? That expansion of the determinant, you have 6 terms. If you have taken 3 cross 3, 2 cross 2, there were only 2 terms, right? Okay, otherwise you can remember this. This is n factorial. In case of n cross n matrix, there are number of terms are n factorial, right? Now, number of different n cross n symmetric matrix with each element being either 0 or 1, right? This is a question something like your PNC, permutation combination, okay? So सोच के देखो, आपके पास लेट से n को मैं कोई भी ले लेता हूं, 3 क्रॉस 3 ले लेता हूं, ओके? सो यू हैव एलिमेंट्स 1 और 0। तो क्या करोगे? डायगोनल एलिमेंट 0 और 1, 0 और 1, 0 और 1, राइट। यहां पे भी आप 0 और 1, 0 और 1, 0 और 1। बट जो भी एलिमेंट यहां रखोगे, यहां तो फिक्स है, यहां जो भी रखोगे वो ये फिक्स है, जहां ये रखोगे वही फिक्स है। मतलब चॉइस आपकी इन 6 में है, 1 2 3 4 5 6। सो 2 रेज टू पावर 6, बिकॉज हर एलिमेंट में आपके पास 2 चॉइसेस है। So when you have taken n as 3, you have choices 2 raised to power 6. Just check करो, n को 3 रखो, 2 raised to power 6 आना चाहिए। n को 3 रखो, 2 raised to power 6 आ रहा है। n को 3 रखो, 3 into 4 by 2, ये भी 6 आ रहा है। n को 3 रखो, 3 into 2 by 2, ये 6 नहीं आ रहा, राइट। अब b और c ऑप्शन में आ रहा है, राइट। तो अगर 4 आपने रखा होता, 4 क्रॉस 4, n को 4 रखा होता, तब क्या होता? आपके पास 4 3 2 1, यानी कि 10 एलिमेंट्स होते। जब आप n को n क्रॉस n को 4 क्रॉस 4 लेते, तो आपके पास चॉइसेस होती 4 3 2 1, यानी कि 2 रेज टू पावर 10 चॉइसेस होती। तो जब n को 4 रखो तो 10 आना चाहिए, तो ये गलत हो गया। इसका मतलब ये करेक्ट आंसर है। यू कैन सी 4 into 5 by 2, तो 10 आ जाता 2 रेज टू पावर, right? So your answer should be 2 raised to power n into n plus 1 by 2. Okay? अगर आपने प्लस वन प्लस टू में मैथ्स पढ़ा है, मैथ्स आपको इंटरेस्टिंग लगता है, राइट, गो फॉर इट। अदरवाइज मेरा सजेशन होगा, यस एडी, व्हाट इज द डाउट? टेल मी द डाउट। ओके, तो टेल मी लेटर ऑन। तो y minus 1, y minus 1, zero matrix, what does this mean? We are talking about n cross n matrices with each element being either 0 or 1. So it can be zero matrix also, because all elements can be 0 also. Here nothing is given about that, right? How come zero matrix can also be 3 cross 3? Zero matrix can also be 4 cross 4. Here nothing is mentioned, and zero matrix is also a symmetric matrix, right? Yes, matrix of order n you can consider, right? All elements are 0. Zero matrix is when all elements are 0. Okay. So maximum value of the determinant among all 2 cross 2 real symmetric matrices with trace 24. Here actually the element should be natural number, not real but natural number. Okay. See what will happen. So if you are writing 2 cross 2 matrix, it is A, B, C, D, right? But because trace is 24, can I write D as 24 minus A? Because the sum of the diagonal elements must be 24, right? And now what will be the determinant value of this? The determinant value of this will be, right, A into 24 minus A minus C into B, right? Now because I want the maximum value of the determinant, right, and B and C are natural numbers, so I will put this as 0. Okay, sorry, not natural number but whole numbers, right? Write it whole number. Okay, the thing is that I wanted to not have negative numbers. Okay, so you can write non-negative or whole numbers, right? So B into C I will put at 0 because I want to maximize this. And if you want to maximize the product of 2A into 24 minus A, where the sum is 24, product of two number maximum will be when both are equal. So 12 into 12 will be maximum. So maximum would be 144. When A would be 12, it would be maximum. A into 24 minus A will be maximum when both are equal. So 12 and 12. Right? You can see the product will be maximum when both are equal. Right? That is the concept of AM greater than GM. Okay, so my answer would be 144. Right? Okay. Now the problem is that time we have taken, right, more time in this. So can you write, okay, this is easy. Because if A is given and he's talking about inverse of A, right? Inverse of A, right? You know that inverse of A is given. But you also know that A into A inverse is identity matrix. That means this into this must be, first element must be 1. Okay, see, 3x plus 0. So 3x must be 1. If 3x is 1, I want the value of 6x. That must be 2. Right? What I am taking is that I am multiplying A and inverse of A to get an identity matrix where first element should be 1. Right? If the first element is 1, so 3x into 1 plus 0 into minus 1. So 3x equal to 1. Right? If 3x equal to 1, I want the value of 6x. That should be 2. Okay. So I'm just concluding it here only. Okay, just take a screenshot quickly. Right? Take a screenshot of the last question. Okay, you can take a screenshot of this. You can try solving this. I'm giving you the answer also. Okay, there is more questions. Okay, this is easy because it is a skew symmetric matrix. Skew symmetric matrix with odd order. Odd order. So determinant must be 0. So this must be 0. So D, none of these should be the correct answer. Okay, this is also easy, but this is your homework. Okay, you can just take a screenshot later on also, you can see this. Okay, I'm finishing the session here only. Okay, you can take this screenshot, you can do it later on. Okay, we will continue. I will take this question in day after tomorrow session. Right, we will take more questions on higher mathematics in that session. Okay, and 26th and July 2nd we will have analysis session of IPMAT Rohtak and IPMAT Indore. Okay, so you can follow us on these different channels. So see you in the next session. Thank you. Bye bye. Namaste. Jai Hind. Thank you.